Welcome back to Math with Mr. Miller. I'm going to be going through some Venn diagram stuff today with you guys, going through some more of that probability as we go through topic 4 in IB Math. Venn diagrams can be really helpful just to see the overall data set laid out for you. Frequently, we try to make it so that each of these little gaps here has just the number of things in that gap, which can be kind of tricky to get based on the information given, because the information isn't typically given to you that way. There's a lot of overlap in the information that they give. For example, the way I know there's overlap in here, in this particular problem up above, is that they tell me 59 students took history, 29 students took math, and 38 took science. Well, if I add up all those students, I end up with 126 students, but they tell me 100 of the students were surveyed. So I know that there's some overlap then. There are students who took history that also took science and things like that we really need to kind of parse out and figure out who really took what. But once we have that information in our Venn diagram, it can be really helpful to see, okay, these so many students only took history, these so many students only took math, these students took both math and science, those kind of things. It can be a great way to see all of that just laid out in one picture and used to find some probabilities of, like, what if I picked a student, what's the likelihood that they are taking both history and science, that sort of thing. So it can be really helpful, things like that. It can also be really great to determine certain things that are mutually exclusive. We can see it right in a picture. Mutually exclusive means you can't be both one of it and another. So for example, history and math would be considered mutually exclusive here if there were no students that took both. You would either only be taking math or only be taking history. In this particular problem, none of these events are mutually exclusive. There are a bunch of students that take one or the other or both. But in the event that you have mutually exclusive events where you can't be considered doing both events, you would have no overlap in some of these circles. A good example of mutually exclusive events is a coin flip. When you flip a coin, you either get heads or tails. You can't get both in one flip. Another example would be if you're rolling a die. In the events we're getting an even number or an odd number. You either get a number that's even or you get a number that's odd. There are no outcomes where you can get a number that's both even and odd. Those things are mutually exclusive. Okay. In a Venn diagram, you can tell something's mutually exclusive because there's just completely no overlap between the circles. So if I had a fourth class here, let's say it was French, if students only took that French course and none of the other three, well, then that would be mutually exclusive events, okay? But in this case, we're going to go through how do I find the numbers that go in each of these different blanks. And I'm going to start out actually with the middle. It's typically the easiest one to determine. Only 4 students took all 3 HL courses for their diploma. So only 4 students took all of the history, math, and science courses. So I know in that very middle, there are 4 students in that overlap, okay? This middle space where all 4 or all 3 of those circles overlap, that's where I have 4 students who are taking all the courses. From there, I kind of branch out. So I know from the other information given to me that 15 took both HL history and HL math. The issue is, those 15 students already include the 4 that we have here in the middle, okay? So if I know 4 of those students took all 3 courses, well then out of those 15, there's only 11 that exclusively took history and math. And I put that in just where those circles for math and circles for history overlap in the very middle. And what you'll notice, I'm going to erase this circle around the 4 real quick so you don't get confused by all the space. But what you'll notice is we can see history and math overlap both where I have my 11, but also in the very middle. And that should total out to the 15 that took both of the courses, okay? And that should happen kind of every time. That's how you can double check that you did it right, is when you go and add the entire space where H and M overlap, it should total out to be the 15. Now, I'm going to erase kind of this extra highlight for when we move on to the next one. It says 12 students took math and science, which means in that full overlap of math and science, I should have 12 people. I already know 4 of them are in the very middle, which means there's only 8 left here between math and science exclusively. If I do the same thing, 8 students took science and history. I know 4 of them really took all 3 courses, so I'm going to have only 4 left taking exclusively history and science. Okay? From there, I know that 15 students took history, 59 students took history. Well, I know in total there were 11 students that took just history and math. There were 4 that took history and science already accounted for. And there are 4 more that took all 3 courses that we already accounted for out of that 59. So if I subtract out that extra 19 students, I end up with 40 that exclusively took HL history. And maybe they didn't take HL math or science, maybe they had to take, who knows, HL theater as one of their HL courses for their diploma. But there's 40 that exclusively took HL history. I then have 29 total students took HL math. I already have accounted for 11 that took math and history, 8 that took math and science, and 4 in the very middle that took all 3. And that's going to total out to, it looks like, 23 of the 29 students, which means I only have 6 that are taking HL math exclusively. And then for my last one, sorry, give me one second. There we go. So for my last one, well, I have 38 that took HL science. So if I take that 38 and subtract away the already accounted for students, well, there was 4 that took science and history. There were 8 already accounted for in science and math. And there were 4 that took all 3 courses. Subtracting those students out, I get, it looks like 22 students that took exclusively science. Okay. The very last thing that we have to do, though, is we need to now double check, does this total up to 100? So in all these spaces, I'm going to add together 40 plus 11 plus 6 plus 4 plus 4 plus 8 plus 22. And I get from that total only 95 students total covered in all of my spaces. That means out of the 100 students surveyed, there were 5 students left over that didn't take any of these courses. And what I'm going to do is I'm going to put them outside my circles. 5 students left. At the end of putting together your Venn diagram, you should check there should be a total of 100 students in the entire diagram because there were 100 students surveyed. Okay? And there is my whole Venn diagram. Now, the things you want to make sure you do when you create your Venn diagram, you should always have your sample space labeled as U, and then you should have each of your circles labeled specifically for the course that they cover. So in this case, his H was for history, M was for math, S was for science. It's really up to you how you want to label them. As long as it's clear, you should be good to go. We can then use this diagram to find specific probabilities. So if I wanted to, let's say, find the probability that a student takes history and math, well, that's going to be the intersection between history and math, and we have to be really careful not to exclude some of the values here. My intersection between history and math is this full portion of 15 students out of the 100 total. Okay. We can also use it to find conditional probabilities. The Venn diagram can be really helpful for that too. So for example, find the probability a randomly chosen student takes math given we know they take HL history. So that's going to read as math given with that straight up and down bar, history. And we have a formula for the conditional probability. Okay, that's going to be the probability of M intersecting H, which we actually conveniently already found up above, divided by the probability that they're in history. And we can do these individual probabilities separate. So the probability of math intersecting history, well, that was 15 out of 100 students. That's all divided by probability of students taking history. Well, there was 59 students taking history total out of 100 of the students, which is going to give me 15 out of 59. We can also see this really easily in the diagram by focusing just on the history circle. We know that they're taking HL history, so if I highlight my history circle here, well, in that history circle, I have a total of 40 plus 11 plus 4 plus 4, 59 students, okay? And I have 15 of them that also take math in this portion here. So then that would give me the 15 out of 59 that I was looking for. Okay, so two different ways, either using the diagram itself by zooming in just on the circle, essentially making history your total, okay, or using the formula that you're given in your formula packet. Okay, there's going to be one more example that I'm going to go through, but if you need to pause, rewind, feel free to do so. Otherwise, I'm going to go ahead and move on to another example here on the next page. Okay, and again, if you have any questions, please feel free to ask. I'm more than happy to help. All right, on this last one, in a survey of 47 students about their favorite animal, 29 students preferred dogs, 32 preferred cats, and 6 students didn't like either pet. It's asking how many students preferred both. So how can we find that intersection in our diagram? So if I draw my diagram out here, I'm going to have two circles, one where they prefer dogs, one where they prefer cats. Okay, I know 29 preferred dogs, 32 preferred cats. The issue is I know there's some overlap because like if we did it like we did in the problem earlier, if I add 29 and 32, I'm going to get 61 students. The issue is only 47 were surveyed, so I know that there's some overlap between dog lovers and cat lovers. So we're going to have to figure out how we're going to find that middle. I know there's some amount in that middle that I can't be too sure about. Okay, so I'm going to put an X there in the middle. I know there are 6 students that don't like either pet, so I'm just going to go ahead and put that on the outside, and I really should label my whole sample space U. Well, in that dog circle, there's going to be a total of 29 students in the dog circle. So I'm going to put on the left-hand side, not in the middle, 29, but it shouldn't include the people already in the middle. So I'm going to subtract out the X that I don't know. Same thing on the right side. There should be 32 cat people that prefer cats total in that circle on the right-hand side. Well, some of them are already in the middle, so the rest must go on the right-hand side exclusively, 32 minus however many fall in the middle. And there's my full sample space, okay? And what I know should happen here is there should be a total of 47 students. So if I take all those spaces added together, I should get 47 students. And there's a way I can solve for who's in the middle. If I combine all my like terms, I'm going to get 29 plus 32 plus 6 gives me 67 minus 1x, because I'm going to have 2 of these x's cancel, equals 47. Well, then if I subtract that 67 from both sides, I'm going to get negative 20 and divide by that negative 1. That means there's 20 individuals total in the middle. So if I redraw my diagram this time with the accurate information, dog, cat, I have 6 people outside of it. I know there's 20 here in the overlap. That means there's 9 exclusive dog people, and then there's only 12 exclusive cat preferred individuals. Okay, 29 minus that 20 gives me that 9. 32 minus that 20 gives me that 12. Okay, so a quick and easy way to find how many people in that intersection there. If you have any questions, again, please feel free to ask in class. I'm more than happy to help. Otherwise, thank you all for watching and have a great day. I really hope this helped with some of the Venn diagram stuff.